Okay, so in this video, this week we covered 8.2. Now, this is an extra worksheet, but I wanted to make sure that for those who weren't in class had a video to reference and to help them um, through this worksheet. So I'll cover some of these problems so you get the idea of what I'm looking for. So in these first set of problems here, you're going to be drawing the angle, much like we did in the other video, or in the other 8.2 notes, except we are going to be starting with radians. So given the radian measure, can you draw the angle? Now, it can be kind of difficult to understand or to see the radian measure. So for instance, if I give you something like 120 degrees, well, that's a little bit easy for our minds to comprehend. We know that this is 90, this is 180, so this 120 has to be 30 degrees from here, 60 degrees from there. It's a little bit easier for us to do the math, right? Now, given a radian measure, that could be a little bit more difficult. We can't really see it as clearly, so I'm going to give us a couple of tips to help us. So, first of all, recognize, that pi in radians is just 180 degrees. So if this is negative 4 pi over 3 radians, which is what this unit is, well, if I convert this to degrees, we learned this last time, I can multiply by 180 over pi, and the pi's will cancel out. And so notice here that we get negative 4 divided by 3 times by 180. If you want to do a kind of a shortcut, recognize again that pi is equivalent to 180. Pi radians is the same thing as 180 degrees. So I can instantly just replace this pi radians with 180 degrees, and there, right now, I have already converted to degrees. And then I just have to punch this into a calculator to find the degree measure. So negative 4 pi divided by 3 radians is equivalent to negative 240 degrees. So I want you guys in all these problems to convert from radian to degrees so that we know how to see the relationship between the two. So negative 240 degrees. Now we have to draw this. So we always start from the initial side. This is the initial side starting at the x-axis. And then we need to draw our terminal side, and the terminal side is the side that rotates from the initial side. Okay? So here's our initial side, and the terminal side will rotate. If you have a negative measurement, like we do up here, you rotate in a counter, or you rotate in a clockwise direction. If the degree or the radian measure is positive, you rotate in a counterclockwise. So because it's negative, we rotate clockwise. So here I go negative 90 degrees, negative 180. This would be negative 270. So I've obviously gone too far. So I know that 30 degrees less than that, or 30 degrees more, I guess, since we're talking about negative, this would be 30 degrees from there, and that should give us negative 240 degrees. So starting from the initial side, we went around right there, negative 240 degrees, or in other words, in radian measure, this is the same thing as we went negative 4 pi over thirds radians. Okay. Now, notice here that we have a fraction, right? This fraction is in thirds, so this is going to be a hint or a tip on how you can draw something in radians without converting to degrees. So I noticed that without this 4 right over here, so let's just say I had without the 4, this was pi thirds. Now I know that again that pi is equivalent to 180 degrees. So that means this right here, this is 180 degrees. When it's negative, this is 180 degrees. So this creates, is like the half circle, right? Now let's imagine I split this half circle into thirds. That's what I'm dividing by. So let me erase this. If you need it, just pause it and write it down. But if I were to take this circle and split it into thirds, a third of 180 is 60 degrees. So that means this would be 60. This would be 60. So again, this would 60, 60, and 60, which would make up 180. So notice here that a third pi, this would be pi over 3. Well, negative pi over 3. Because I just went 1/3 of a pi measure. This one would be negative 2 pi divided by 3 because I went 1, 2. 2/3 of a pi circle. This would be 3 pi over 3, or just pi. Sorry, this would be negative pi. And then I went another pi thirds, which gives me 4. So this would be negative 4 pi divided by 3. So hopefully this is a way to help you see how you can measure something in radians without having to convert to degrees. Now over here in this problem, we have pi over 12. So this means that pi, again, which is 180, is being divided into 12 parts. So 180 divided by 12 is 15. So that means this top half is divided into 12 parts of 15 degrees. 15 degrees, 15 degrees, 15 degrees. And that also continues on to this side over here. This pi of a half circle is also split into 15 equal degrees. Now if that's the case, notice here that 24 pi over 12, so if I went one more 12th more, I get 24 pi over 12. Now 24 over 12 is just 2 pi, or 360 degrees. So the difference between these two measures is 15 degrees, or a pi over 12. So that means right here, this angle will come out to be 15 degrees. This angle right here is 23 pi over 12. And this last 15 degrees is what would get me to 2 pi, or a full circle. Like that. Now I still want you guys to convert. Now let's convert this and see how this compares. So if I convert this to a degree measure, so I know 23 and I know pi is 180 degrees, so I'm going to change that to pi radians is 180 degrees divided by 12. So if I use a calculator, 23 times by 180 divided by 12, I get 345 degrees. Now a full circle is 360 degrees, right? So notice that this is just 15 degrees less than 360. And there you go, that's exactly what we have. This right here is 345 degrees, which is 15 degrees less than 360. Okay, so again, you don't have to think of it that way, but it's what helps me measure these angles. So go ahead and go through the rest of these and convert and draw the radian measure. Now there's one more section down here, and that is to find a positive, so one positive and one negative coterminal. So you're going to need two responses to these questions down here. So I'll help you with the first one or two. Before, when given in 8.2 notes in that video, we were given, say, something like 120 degrees. and 120 degrees in order to find a coterminal angle. So let's remind ourselves what coterminal was. So here, let's say I had 45-degree angle. A coterminal angle was an angle that shared the same terminal side, and this is the terminal side. The terminal side is the side that rotates from the initial. And so if I wanted to find a coterminal angle, all I had to do was add or subtract 360 degrees from 45, and that way I found another angle that shared the terminal side. Okay, so again, to find coterminal angles, all I have to do is add 360 or subtract 360 to find other coterminal angles. So there's infinite coterminal angles. So here, using radians, I don't want you to convert here. I just want you to use purely radians. Now, if we're going to find coterminal angles using radians, we have to add 360 degrees to these radian measures. And so remember that 360 degrees is equal to 2 pi in radian measure, 2 pi radians. So for this one, let's say I take 2 pi over 3. Let's add 2 pi to this radian measure, and we can find a coterminal angle. Now, if I'm going to add these together, they have to have a common denominator. So this 2 pi is over 1. Now, if I want to get a common denominator, I'm going to multiply this denominator by 3. But if I multiply the denominator by 3, I have to multiply the numerator by 3, because 3 over 3 is 1. Thus, we're not changing the value of this expression. So in any case, this becomes 2 pi over 3 plus, that's going to be 6 pi over 3. Now that they have a common denominator, I don't add the denominators, I add the numerators. So 2 pi and 6 pi, that's equivalent to 8 pi divided by 3. So here is a positive coterminal angle. Now I want to find a negative. So I'll take 2 pi over 3, and this time I'm going to subtract 2 pi. Now, to avoid making this step again, which I don't need to because I already know that that I can use this same value, 6 pi over 3, because 6 pi over 3 is 2 pi. So I'm going to subtract 6 pi over 3, save myself some time and cut out this spot right here, that step right there, because I don't need to do it again. And now I have 2 pi minus 6 pi, which is negative 4 pi divided by 3. And so here I have a negative coterminal angle. And there you go. That should get you to where you need to be for all these problems. Remember that I'm looking for a positive and a negative coterminal angle here. And you can do the same thing. You just have to add and subtract 2 pi from each of these radian measures. Add and subtract 2 pi to all of them to get what you need. Okay, so hopefully that helps you guys get through this worksheet, and make sure you let me know if you have any questions.